Hello friends, my name is Jonathan and I am from Assam. Again, I will teach you physics part of class 10. Okay. Now, before moving forward to the physics part of class 10, I want to say something that is quite known to all of us that the second pandemic or the second wave of corona is here. So it is my kind request to all of you that if it is not needed, don't go outside of your home. Okay, stay at home, stay safe, right? Live a healthy life, right? So let's begin. Okay, basically we are going to have 5 lessons of physics in class 10, and those lessons are like this. Our first lesson is going to be light, reflection and refraction. Okay, second lesson is going to be human eye and colorful world. Okay, third lesson is going to be electricity. Okay, and the fourth lesson is going to be magnetic effects of electric current, and the fifth lesson is going to be sources of energy. Okay, these all are our 5 lessons. Okay, we will move forward to all of these lessons by one. Okay, now first we will discuss about the first lesson, light, reflection and refraction. Okay, before moving forward to the light lesson or knowing about the two phenomena, reflection and refraction. Okay, here is two phenomena we will discuss, reflection and refraction. Okay, before moving forward to the reflection and refraction phenomena, we should all know that what is light, right? How light works. Okay, what are the properties of light, right? See, basically if I say light is a packet of waves which have actually energy. Okay, simply you can say that light is a energy source. Okay, again we can actually write some properties of light, and those are like this. Okay, now I have written here some properties of light. Okay, so and their definition of light. Light is a form of energy which enables us to see the objects, right? See, if you are in a room and that room is completely dark, the simple question is, can you see some object or can you see anything? The question is going to be no, right? Because if there is no light, you cannot observe. Okay, when we will discuss about reflection, you will understand the phenomena by which we can actually observe something with the help of light. Okay, now the second part is properties of light. Okay, the first property is light is an electromagnetic wave. Okay, when we will discuss about electromagnetic wave, since you are in class 10, I will give it the meaning of electromagnetic wave simply in a simple manner, that electromagnetic wave is that wave where that wave is generated when there is some kind of vibrations both in electric field and magnetic field, or you can say in presence of electric field and magnetic field. Okay, again some knowledge about electric field and magnetic field will be necessary, right? But when we will discuss about electricity lesson and when we will discuss about the magnetic effects of electric currents, then we will understand the meaning of electric field and magnetic field. Okay, so we will keep these definitions till that part. Okay, again the second point is the light requires no medium to travel. Okay, see, our sound that requires some medium. Okay, if there is no medium, we cannot hear our sound, right? But light is not like that. Light never requires any kind of medium. It can pass through vacuum. Vacuum means what? There's nothing. Okay, there is no source to carry light from one medium to the, or from one point to the other. That means what? Light requires no medium. And the third point is light always travels in a straight line. See, there is a condition. If it is traveling in a single medium, light always travels in straight line. That's why it is always known as rectilinear propagation or rectilinear propagation. Rectilinear means straight line. Okay. And the fourth one is light has dualness, wave and particle. Again, this is a property of light. Okay, wave means we all know that sound wave and light wave, those are wave. And particle means light is a source of energy. Okay, or light is a form of energy. Again, that energy comes from what particle? That particle is known as photon. Okay, which gives energy to the light. Again, when you will discuss in higher physics, or when you will go to the higher classes, you will understand the meaning of particles and wave nature, and you will understand the meaning of photon. Now we will not discuss about that much of actually, because it will be a little bit complicated. And the main property, okay, the main property of light is light has a actually high speed of propagation. That means that speed is 3 into 10 to the power 8 meter per second, and nothing, I said no, nothing can move at this speed. Okay, always remember that nothing can move at this speed. Okay, so these are some basic properties. Again, after that we will move towards the phenomena reflection and refraction. First we will discuss reflection. Okay, now we will move towards reflection part. Okay, that actually is reflection. So before moving forward to the reflection part, we should actually know the proper definition of reflection. Reflection is that phenomena in which, if we consider there is a source of light, okay, that from that source a beam of light is coming. Okay, when the beam of light is coming, if there is a polished surface, okay, that beam of light will incident on that polished surface. Okay, once this polished surface reaches the polished surface, what will happen? It will again bounce back from that polished surface to that medium from which actually that beam of light is coming. Or you can say the medium where that source of light is kept, and from that source that beam of light is coming, and once it reaches that polished surface, what will happen? It will bounce back to that again same medium. Okay, see in a boat, if I consider this as a polished surface, okay, polished surface, okay, I will consider this as this point as a source of light. What will happen? From this position, a beam of light will come. Since this beam of light is coming from this direction, we have to give a arrow mark. And again remember, in this light lesson, this arrow mark has a great importance. Okay, if you do not give this arrow mark, there will be no meaning from which direction that light is coming and from towards which direction the beam of light is going. Okay, once it reaches this polished surface, what will happen? It will again bounce back to the same medium. If we consider this as a medium A1 or medium air, where the source is actually kept. So from this source, the beam of light will come and it will incident on this polished surface, and after the incident, what will happen? That ray will again bounce back. Okay, sorry for the you guys a little bit of. Okay, now it will again bounce back to this main source or the similar source. This is the phenomenon of reflection. Again, there is two laws of reflection. Okay, two laws of reflection. Okay, till now this figure is not complete. Okay, once we will discuss this laws of reflection, you will understand how it is or why it is not complete. Okay, first we will give some names actually. Give name A, this as O, this as B. Okay. As I said, there is two laws of reflection. The first law is the incident angle is always equal to the reflected angle. Okay. That means what? There is something okay, that we have to actually draw. Till now in this figure we have only two components. One is the incident ray and other one is the reflected ray. That means what? That AO is the what? Incident ray, okay, and that OB is what? Our reflected ray. But according to the first law, that incident angle, not incident ray, that incident angle is always equal to the reflected angle. But to measure the incident angle or the reflected angle, we are going to need one more line, and that line is nothing but normal to this polished surface, and we have to draw like this. Okay, this is the normal, and we will give it name ON. Okay, this angle is known as incident angle, and since the first law is I, it will be always denominated by I, and the second angle is known as reflected angle, and it is denominated by small r. Okay, that means that angle AON is the what? Incident angle. Okay, and that second angle, and OB or angle BON, you can name as you want, is the reflected angle. Okay, this angle AON is the incident angle, and angle OB is the reflected angle. Okay, now according to the first law is that the incident angle is always equal to the what? That reflected angle, right? That reflected angle. Okay, and that incident angle is represented by what? Angle I. Okay, and that we have to give equal sign because that this angle is, though in this diagram as I have drawn with a single hand, or you can draw, I have drawn freely, that's why these two equal angles are not actually similar. Once you draw in exam or once you draw in book, always use or always make these two angles same. Okay, this angle is always equal to this angle, that's why we have to give a equal sign. Again, that angle is denoted by angle R. That means this incident angle is always equal to the reflected angle. Okay. Again, this second law. That second law actually says that incident ray, okay, that normal, okay, and this reflected ray always lie in the same plane. See, consider that you are in a classroom, okay, you are going to have a floor, okay, and consider that floor as a plane, okay, and just consider that I am teaching you physics, okay, I will remain standing in position in that floor, okay, you will sit on that you will sit in that bench, what, that bench in this same floor, okay, that means we can say that all of us, right, in that classroom, all of us in a single plane, okay, as like that. In this case, if this is a single plane, okay, and if we consider this point as a single point, okay, and look closely that this incident ray incident on a single point, and from this point again that reflected ray reflected, okay, and in this single point, then always there as a whole we can say this, if this point in this plane, then we can say that ray, incident ray, that normal and the reflected ray will be on the same plane, right? Okay, that's saying that second law is going to be, this is the second law. As I was talking about this second law, this is the second law which says the incident ray, the normal and the reflected ray are always lie in the same plane. See, when I was drawing, maybe it is quite difficult for you to actually observe. Now look closely in the board and draw it properly as I have drawn and I have written some points. Okay, so now draw closely in the figure that I have drawn a polished surface where these actually dotted lines are here, this is the polished surface. Okay, in this polished surface, what happens? From a source A, we have incident a beam of light. Okay, from that direction, from A to O, that's why I have given an arrow mark from A to O direction. Okay, once it incident on a polished surface, what is happening? That ray is again reflected towards that single or similar medium. That means towards O to B direction. That's why I have given this arrow mark from O to B direction. Okay. Till now, that figure is actually good. But once we have to discuss the laws of reflection or two laws of reflection, you can say, or you can give the heading as not two laws of reflection, you can give the heading as laws of reflection. Okay, you don't need to give the heading as two laws of reflection, you should give the heading as laws of reflection. Okay, see, in this case we have laws of reflection. The first law is that the incident angle is always equal to the reflected angle. That means we have to draw one line that which will give us the incident angle and the reflected angle. That line is the normal. And normal to what? Normal to that polished surface. That means that ON will make 90-degree angle in both the sides. That means in the left side or the right side with the what? Polished surface, right? So it will give us two angles, angle AON or angle NOB. Angle AON is known as incident angle, or angle NOB is known as reflected angle. Okay, we have actually denominated angle AON as I, okay, or angle NOB as R. That's why you can write the incident angle is always equal to the reflected angle. Then we can give, right, or angle I is angle equal to the, or is always equal to the angle R. Again, the second law is the incident ray, the normal and the reflected ray always lie on the same plane. See, as I told you in the earlier diagram that a little bit ago, that if I consider a single point on that polished surface and that beam AO incident on that same point, again from that point that OB ray is reflected, right? That means till now that two ray, angle AO, so not angle AO actually, that AO beam and the OB beam are in the same point. Again, we have drawn a normal and that normal is again on the same point, right? That means we can say if those three lines are in the same point, or you can say and that point is lying on the same polished surface, you can say that the incident ray AO, the normal ON, or the reflected ray OB is lying in the same plane. So these two are the basic law of reflection. Okay. Okay. Now our second point is going to be spherical mirrors. Okay. We all have mirrors in our home, right? We have mirror. Those mirrors are known as actually plane mirrors. Okay. Plane mirrors are like simple mirrors. If this is a mirror, this is a plane mirror. But the thing is, though this is a mirror, na? Have you ever wondered why you can actually see yourself or observe yourself in those mirrors? What are the reasons actually? Okay, there are certain reasons that, but see, first, what you do, you have windows, okay, and your window have a glass too, actually, right? Just look through the window. What will happen? You are not going to see yourself, or you are not going to observe your images, right? You will observe certain things, those are actually behind those window. But in case of mirror, it is a glass too, right? But in that mirror, you can see yourself. It's a quite actually complicated thing. See, what happens in case of a mirror or a plane mirror, we always take a glass, okay? Though we have taken a glass, what happens in the later part or in behind the glass, what actually happens? We do the polishing, or we actually darken the behind part of the mirror. Okay, as I have actually did to make you actually understand. Okay, this is a plane mirror. Okay, if this is you, okay, standing in front of the mirror, you are going to observe yourself in this mirror. But in case of a glass, okay, if you are standing in front of that glass, what will happen? You are going to observe only the things that is behind that glass. Okay, that is some other boy or girl. So this is actually the reason why you can see yourself in a plane mirror. Okay, so now we will actually move towards the next part, and that part is actually spherical mirrors. Okay, spherical mirrors. Okay, spherical mirrors. Look closely at in the heading spherical mirrors. The word which is actually familiar to us, mirrors, but for this time we will actually not think about that word mirrors. The more interesting word or more important word is that spherical word. That means a sphere, right? We'll consider this is a sphere. Oh, sorry, this is not a proper sphere. Okay, this actually happens when you try to draw with a free hand. Okay, now see, this is a sphere. Okay, and sphere is a three-dimensional thing. Okay, always we all know that. And that sphere we're gonna have a center. Okay, now what we will do, we will cut this sphere from this side. Okay, and we'll cut this from this side. Okay, now what we will do, we will separate these two parts. Okay, one will look like this. Okay, and the other part will look like, sorry, this kind of things will happen actually. What will happen, I am actually draw with a free hand. That's why sometimes what will happen, that circle is not going to be proper circle, that straight line is not going to be straight line. But once you will write in your copy, use proper compass, proper scale, okay, then you can draw this actually properly. Okay, till now, as I have told you, in case of a plane mirror, if this is only a glass, this is not a mirror. Just consider these two are the part of a glass. Till now, these are not mirrors. Once we polish the other parts, what is going to happen? It is going to be a mirror. Okay, it is going to be a mirror. Okay, this mirror is known as what? Convex mirror. Right? Convex mirror. And this mirror is known as what? Concave mirror. Okay. Till now we have drawn the actual two mirrors, or two kinds of mirrors that actually spherical mirrors include. Right? Spherical mirror includes, one is concave mirrors, and the other one is concave mirrors. Okay, these are two basic actually mirrors. They actually we can get from a sphere. Now, in case of a plane mirror, things are quite simple. Okay, you just have to stand in front of a plane mirror, then you will just observe yourself. But in case of spherical mirrors, things are a little bit different. Okay, not a little bit, it's quite different. We are going to have some new terms actually, and those terms are like center of curvature, principal axis, and you can say about radius of curvature, focus, focal point, focal length. Lots of terms are there. Okay, now we'll discuss about those things too. Okay, now we will discuss about those terms that I have actually said. First, we will draw a actually concave mirror. These are actually, this is we done to make it a polished surface. That's why we actually can get some images when the polishing is done. See, as I have said, if you draw a sphere, okay, if you draw a sphere and you cut two faces, and from this face is nothing but this face, no? That means this concave mirror we are actually getting from a sphere, okay. This sphere is going to have a center, okay. For this portion, this is going to be center too, right? That's why you can say this center is going to be center for this mirror too. Understood? And that center is known as center of curvature, okay. And that center is actually denoted by C, okay. Again, as this spherical mirror based on this center, there is going to be a center in the reflecting surface too, right? Though we consider that this is the center, this center of this reflecting surface is known as pole. Again, it is denoted by P, okay. Now what we will do, we will first join this line from P to C. Now look at this sphere again. If I join this line from here to here, what this line actually called? This line is actually called radius, okay. If I draw one more line from here to here, what is going to be this? This is going to be again similar radius, okay. That means what? The line drawing from center to the center of this reflecting surface is what? Radius. That means what? This PC is going to be what? Radius. But since this is a curved surface, we have to write radius of curvature, okay. This is the radius of curvature. Understood? Okay. Again, there is one more thing. If we draw a point at the very middle of this line PC, that point is nothing but focus, okay. Again, there is a distance between P and F. That distance PF is known as focal length, okay. And that F is known as principal focus. Okay, I will draw, or I will write all these things, okay. It will be a little bit beneficial for you. See, that F is known as principal focus, right? P is known as pole, right? PF is known as focal length, right? That PC is known as what? Radius of curvature, okay. And this is done, okay. Radius of curvature done. That C is nothing but center of curvature, okay. There is again one more term. This is M and N, okay. This Mn is the cutted portion from that sphere, right? And this Mn region is known as aperture, okay. This Mn is known as aperture. Now we have to understand the meaning of aperture. What actually aperture is? Okay, those who actually use some DSLR cameras or some kind of cameras, those aperture what is actually using kind of cameras, okay. The exposed region of the mirrors, actually those exposed region is actually exposed to what? Exposed to light or incoming light, right? With the help of that incoming light, you can observe something, or you can going to get some image in their mirrors, or you can, or say cameras too, right? in our eyes, this is the only portion, or this is the only portion that is exposed to light, okay, or in this eye this is the only exposed region. My whole face is not an exposed part, okay, this is the only exposed part, right? So for my eyes, this portion is going to be the aperture, right? Understood? So this is the aperture. But the definition of aperture in case of a mirror is nothing but the diameter of the reflecting surface is known as aperture. See, as I said when I was talking about the pole, I have considered this point as a center of this reflecting surface. Once I draw the line, dotted line from this center, this dotted line is going to be what? Radius kind of thing, right? Okay, this is the radius. Once we twice that radius or multiplied by 2 that radius, what we are going to get? We are going to get the diameter. I hope you have understood the meaning of aperture right now, right? This is the aperture. Now you just draw this figure and write those terms. F is the principal focus, P is the pole, PF is the focal length, PC is the radius curvature, C is the center curvature, M is the aperture. Now there is one more important thing is there. We have drawn this PC, right? We have drawn that F part, we have drawn the aperture, we have drawn almost everything. But one thing is late. Okay, that line is, if I draw or if I extend this line from here to here, okay, that line which is actually passing through center of curvature C, focal length or the focus, principal focus F, and the pole is known as principal axis. Okay, these are the main things. Okay, so we can write down or you can draw the figure like this, but we have to actually write this all part. If there is a question, draw the basic terms or draw a spherical mirror and identify the basic main terms. You have to draw like this and you have to identify all the points that is in the figure. Okay, then you will get the proper marks. Okay, so this is the main thing. Okay, these are the things that we have to discuss in this class. This is going to be part 1 for this light lesson. Again, the part 2 is coming maybe in this week. Okay, and I will inform you. Just subscribe to my channel. Then you will be getting the information or the notification of the second video. It is actually coming by this week. So now the main thing is, it's your responsibility right now to observe all those things that I have mentioned in this video. If you want, you can keep a note. Okay, then if you have any doubt, if you get any doubt, any kind of doubts are there, you can ask me questions in the comment sections. Okay, thank you and just stay safe. Thank you.